Okay, hopefully everybody can see the screen with a bit of luck. So welcome to the September Edinburgh Branch meeting. We'll run through the agenda here. It's a little bit of welcome apologies in a minute, some IOSH and branch group events. We'll look at next month's meeting and then we'll introduce today's guest speaker. So if we go for our usual welcome, it's a quick thank you for the Edinburgh Branch members that have come back to us and to dial in today. We appreciate that. Thank you. And to any other branch members from Scotland or anywhere else around the UK and any of our international visitors that have dialed in to join us, you're welcome and thank you for doing so. We've got some committee apologies at the moment. Steve McCann, who's the Vice Chair, Julie Proctor, Branch Secretary, and Rachel Doyle, who's Group's Liaison. Out of any other of the Edinburgh Branch members, is anybody else aware of any apologies? If you would like to shout them out or even put them in the chat function, and we'll be able to record those and pick up on them in due course. Is anybody aware of anything? No, stop on silence. Okay, thank you. Couple of events then. West of Scotland Branch has got a legal update from the BTO solicitors in Glasgow. Still a Zoom meeting, but that's dated for the 30th of September at 1 p.m. We've also got the Highlands and Islands. They're doing a European Marine Energy Centre Zoom meeting on the 11th of November at 3 p.m. And we've got the IOSH Environmental Waste Management Group. They're doing a webinar on Wednesday, the 8th of September, which was yesterday. That was really useful. I'll need to thank the secretary for that. Hopefully somebody made that one. Shame that was so short. Next month's meeting will be on lifting operations, where we have Stuart Seath from Sybil's Training will be joining us to give us our presentation on that. And for today, I'd like to introduce Jarl Coldrick, who's the Head of Technical Sales at ProGARM. And Jarl's going to be telling us why we should protect our workforce against arc flash for those that have that problem. I've known Jarl for a number of years now. I knew him about a couple of companies ago previously. He's very knowledgeable. He knows his subject inside out, and he's one of my go-to people when I need to discuss anything with arc flash because of his knowledge. He's also presented in numerous wind industry forums as well in the past, such as Renewable UK Health and Safety event when we were able to meet face-to-face all those years ago. So yeah, I'd like to pass over to Jarl, and hopefully we'll be able to educate us all a little bit further on the risk with arc flash. Jarl, it's over to you, sir.
Thank you so much, Simon. And it's honestly a great opportunity to be presenting today. And also very thankful for all those that have come on. I'll just start by sharing my screen. Hopefully we shouldn't have an issue. So just screen 2. Hopefully you can see that okay.
Yep, we're all loud and clear, mate.
Excellent. Okay. So thank you everyone for joining today. And I guess for you, we want you to get as much out of this as possible. And we've actually worded the title as everything you wanted to know about arc flash and more. So it is great that you've come on to actually learn more about arc flash, and we are here to be able to provide further advice. There's much misunderstanding out there when it comes to arc flash safety, especially in the UK and in Europe. America might be a little more advanced, but we are rapidly catching up, which is an excellent sign. So we'd like to also encourage as much interaction through this presentation. We don't want anyone falling asleep, and would be great be very happy to answer any questions throughout this event, and also at the end of the event, I'm sure there'll be some chance there too. So we'll just start off by defining what an arc flash actually is. And I'm sure many of you would know and come across an arc flash. You may even know people that have suffered from an arc flash. But the actual definition of an arc flash is the light and heat produced as part of an arc flash, an arc fault. And that ultimately comes from a low impedance connection, such as air. And in simple terms, it's one current trying to jump from one side of a conductor to the other side. So every time the current is trying to jump from the other one conductor to the other conductor, it causes instantaneous discharge of electrical currents. And that in effect actually causes an arc explosion. And that can be likened to a bomb. It releases extremely high levels of energy. Heat and light are released in fractions of seconds. So this happens in milliseconds, but the results can be devastating. It can reach temperatures of 19,000 degrees Celsius. And to put that into context, it's 4 times hotter than the surface of the sun. It can also give a serious blast and a high pressure wave that can damage eardrums, damage hearing, and even strip away garments. So it's a very serious risk that we need to protect against. Just like to show a video now, which is actually a slow motion video of an arc flash. This isn't real life. This is a mannequin that's been tested, but you can just see the energy released from an arc flash. So I'll just play this now. So it's a short clip, but it just shows the intensity. If you look on the left top of the picture, you can see the molten metal that's been spitted out as a result of the arc flash, and also the intense heat and the smoke. You can't even see the mannequin there. So it's a huge amount of energy in a very short space of time. So when and where does an arc flash occur? There are many industries where an arc flash actually does occur. And one of those environments is an industrial electrical environment. And so you may have electricians, senior electrical engineers, or authorized persons, or low voltage engineers working on a factory floor, or it could be on a manufacturing plant. And even hospitals, they would have substations powering the equipment in a hospital. And so the electricians that are working on these substations actually come up against this risk. And now even electrical vehicle, EV manufacturer and maintenance. So when installing the batteries, that they would come up against this risk. Then you have the power generation environment. So that would be obviously include traditional environments, but also renewable environments such as the wind turbine maintenance. And that's Simon's background, who's on this call today. And then you've got the utilities environment. So anyone breaking ground in an electrical, gas and water industry. And interestingly, many of the underground services are unmarked in the UK today. So if you're working in a gas or water or electrical industry, many of you will already know, but the electrical service is the top level, and then you have the gas and then water. So a water company would have to bypass electricity and gas before being able to reach the water service to make a repair or carry out whatever's needed to be done. So that there are many strikes happening, underground service strikes happening a day, which we'll come on to later. And then those installing streetlights. And then you have the rail sector. So there's electrification and maintenance required there for the power, the substations that's powering the overhead lines, or it could be powering trams. And then you've got the petrochemical industry. So those that have the risk of flash fire, and we'll come on to this a bit later on the difference between an arc flash and a flash fire. So this video here, some of you may have seen this before, but it's an industrial electrical arc flash incident. We're not too sure on what actually happened to the person that was affected by the arc flash, but it's an insane arc flash, and it's in a confined space as well, which doesn't help. So we'll just play this now. So that just shows how scary it can be. And then we'll go on to the next video, which is an example of a underground service strike. This was actually outside the House of Lords in London. There you can see he's trying to get away. You can find this video on YouTube as well. I believe this person suffered second-degree burns and was in hospital for over 8 weeks. And the other person, who was an older person, he still suffers from trauma today. So there are many reasons why an arc flash does occur. One reason could be the fact tools or equipment inadvertently touch live conductors. Another reason could be faults or mistakes in isolating equipment, such as lockout and tagout. And then there is such thing as equipment failure. Things do wear out, so there's the wear and tear, and that could be because of dust or corrosion, but even rodents that can cause damage to switchgear. And then you have the cable strikes, as we can see here. And there are currently around 150 to 160 cable strikes recorded per day, which is an insane amount. So there's only one winner when it comes to arc flash versus the operative. An arc flash can cause skin burns right up to 3rd-degree burns, can cause damage to the eyesight due to the sheer high intensity of the flash and UV light. Hearing loss can be caused by the significant sound of an arc flash, and then loss of memory, and even burns from molten metal and skin infections caused by, could be that your operatives aren't wearing arc flash clothing today, and they could be wearing fibers such as nylon and polycotton, and if that melts into the skin, that can cause skin infections. And then other physical injuries. It may not be the arc flash that causes the fatality, but other injuries like being blown off ladders and into other objects. So it's no exaggeration when we say the implications are certainly life-threatening, and they're certainly life-changing. So we've got a video here. It's around 4 to 5 minutes long. So we'd like just for you to sit back and enjoy this, but this is from a real-life incident. And this person actually received an arc flash, but he was wearing the right protection, although he wasn't wearing the right gloves or a SNU to prevent him getting burns to his neck and hands. But he goes over the importance why it's so important to protect against arc flash. Can everyone hear the sound okay, Simon?
It's not started playing yet, but we were hearing the sound on the previous videos.
Brilliant.
I received a call, I think it was mid to late morning, and it was from Eddie's teammate, Liam. He informed me that Eddie had had an accident and that he had suffered an injury. He informed me that it was an electric, that the ambulance were en route, that he was possibly going to go to hospital because it looked quite bad. And I said, look, let's just deal with Eddie, get the paramedics there, and then we'll start, you know, going to site and having a look and seeing what's happened. But the most important thing is Eddie and his health right now. For me personally, yeah, I was scared. I was pretty worried.
We got a telephone call from a supervisor to say that Eddie had a cable strike. The first thing that runs through your mind is, you know, is Eddie okay? But then you start thinking about his children, because we knew he had a young family and a wife and things, and having children myself, that was my concern for Eddie. You know, is he going to come back to this? Is he going to work again? So it was quite hard. We, as a team, we all took it quite badly. Sorry. It's just thinking about it as well. It just brings back memories. So, sorry.
And when obviously the arc flash hit me, that happened ever so fast, and then everything else happened. It sort of went in slow motion. It was just these thoughts running through my head. The main one was obviously my little boy, but also obviously family, my job. Also worried about the physical injuries. I had burns all over my hands, down my neck, inside my nose, inside my mouth, around my face. But obviously, because I was wearing this PPE, it didn't touch my chest, my legs, under my arms. So my body as a whole was completely fine. It's one of the things you think, oh, it's never going to happen to me. I know what I'm doing in this game. I've been doing it years, and obviously when it does, it's a massive shock to you and your family. And it doesn't affect just you, it affects a load more other people. I drove into work as I do. Obviously I spoke to my supervisor, which had quite an important job had come in. It was close to a railway line. I pulled up to site, unloaded my van, did all the usual things you should do, obviously. The site set up, Kat and Jenny. Started to break the tarmac away with a breaker. And obviously when we removed the tarmac, the ground underneath was pretty hard. We couldn't get the shovels in or get the grafters in, so the plan were to obviously break up the hard ground with the jackhammer. And unfortunately, when I was doing that, the jackhammer just threw straight into the ground, and that's when I hit the cable.
You know, we go to work, we expect to go home. That lad didn't. He nearly never went home. But I've seen the clothing that he had on that day, and you know, we need to get it out there that it's not about money. It's not how many jobs you do in a day. It's how you do that job and how you do that job safely. But most of all, you must wear this PPE. If you don't wear that PPE, you could be dead. Just one cable strike.
Every day I'm sending these guys to go out to work in what is a high-risk job. I think this whole thing around PPE and me as a manager, but me as a person, is actually, it's about everyone's safety, it's about everyone's health and well-being, and that's kind of the way we need to start thinking about it, not as a job, but as actually a way of life, protecting one another and looking out for one another, which is key.
I can't tell you how important it is to make sure you're wearing your full PPE. It's comfortable, lightweight, and I can't see why people wouldn't wear it. If I wasn't wearing my PPE, it'd probably been a different story.
So that's the end of that video, but a real life experience, and a very interesting and just from real life, it's so much more impactful. So Eddie we're thankful for him, and I'm sure he's appreciative of wearing the right PPE, but he certainly is continuing to raise awareness and the importance of wearing the right PPE when there is a risk. So we'll be thankful for him. We'll just go on to the next slide with regards to some facts and myths about Arc Flash. With the BSIF, British Safety Industrial Federation, we actually sent out a survey to many health and safety contacts and electrical engineers, and some of the findings were astounding. Just listing off some of these points here, 80% of responders believed existing government legislation is too ambiguous. 90% of the responders believe that there's a pressing need for government to develop more specific guidelines and legislation surrounding Arc Flash. 84% of the responders claim they understand the risks associated with Arc Flash, but then 78% responders didn't know the correct government guidance, such as the HSG 47, which is relation to underground services. And then 50% of the responders actually consider it to be the employee's responsibility to self-educate on Arc Flash when we know it's the employers. And 57% of the responders admitted they or someone they work with have suffered from an Arc Flash strike, which actually is a very high percentage. So some very good points to take from this call. So just a bit about flash fires. It certainly isn't the same as an Arc Flash, but it's still a great risk. And a flash fire is a sudden, similar to Arc Flash, is a sudden intense fire, but that's caused by ignition of mixture of air or a flammable substance. And that can happen in several industries. It could happen on a chemical plant, such as a refinery, or could even happen with those delivering chemical substance. So like fuel lorry drivers, the tanker fillers, they would actually have that risk. And then utility workers that actually work in and around gas mains. So it is essential for the operatives to be protected against the flash fire risks. And the relevant standard for that is the ISO 11612, which is the clothing to protect against heat and flame. But what we must know is that Arc Flash isn't the same as flash fire. So Arc Flash will provide flame-resistant protection against flash fires, but flame-resistant garments won't necessarily protect against Arc Flash. And that's because there's still quite a sheer difference between both a flash fire and an Arc Flash. Flash fire can reach temperatures of 3,000 degrees, and Arc Flash can reach temperatures of 19,000 degrees. There's a significant difference. The other thing about flame retardant testing is that it only measures the resistance against ignition of the fabric and the seams, whereas an Arc Flash tests the whole heat transfer, the radiation, the electrodes of the whole garment and the construction of the garment and its components. So that's essential in an Arc Flash, because as we saw earlier on, an Arc Flash is likened to a bomb. It can literally tear open garments. So it's essential the components are strong enough and can handle the intense energy from an Arc Flash. So just summarizing this section, employee protection, what can be done? The employers have the duty to protect their employees against risk of injury and other hazards. And there's a hierarchy to safeguarding your workforce. That can include reducing the exposure of operatives to the risk. That's number one. Number two is to define and enforce safe working practices to reduce the risk. And that, if you've got a risk of Arc Flash, you can do that by undertaking an Arc Flash study. Now that can be done internally by one of your senior electrical engineers, or it can be done externally by an electrical consultant. And number three, and whilst it is the last line defense, is the PPE, but it's still a defense because often the risk cannot be totally eliminated. So we just want to go over the importance of specifying the right safety level without compromising. Now, it's essential that Arc Flash PPE does conform to the general PPE requirements, the EN ISO 13688. So we would appeal to you to actually look at this and make sure that garments aren't certified with old certification. So standards like the EN 340 is a very old standard, and it just means that if the garment hasn't been tested, it means the garment hasn't been tested for a very long time if it refers to the EN 340. It's also essential to look at the care label inside the piece of PPE or the garment. And a good care label has good information like the CE marking, European standards with which the product meets, the wash care instructions, and so on. And some of the requirements of the EN ISO 13688 standard does include the fact the PPE should not affect the health or the hygiene of the wearer. It also sets a maximum usage of certain materials such as chromium and also a release of nickel. And materials should be selected that minimize the environmental impact. And that's important today as it ever was. This standard won't necessarily have a pictogram on the care label of the garment. However, you can find this out by contacting your supplier or the manufacturer of the product itself. So when it comes to protection standards, we're going to focus on the Arc Flash standard today. But the Arc Flash standard has recently been upgraded, and this supersedes and replaces the 2009 version. Now, there is a new definition as part of the updated Arc Flash version standard, and that is the ELIM test requirements, which we'll come on to a bit later. But there's also new requirements such as the thermal stability of intermediate layers, the volume resistance, the material requirements, and then the new test procedure for thermal resistance of sewn threads, and then a new symbol for the marking. So as you can see on the right, you have the two triangles there, which relates to the 2009 IEC 61482, which is the Arc Flash standard. But the new symbol is now the Arc Flash symbol you can see in the hexagon there. So there are two test methods. You've either got the open arc test method, which gives 3 values. It used to be 2 values, only ATPV and EBT. And both those values still, they will still give off the risk of the potential chance of a 50% probability of second degree burns. So there's always been that element where companies haven't gone with the open arc test method for that very reason. However, ELIM has now come into place, and ELIM actually gives 0% probability of a second degree burn. So that is, if a Arc Flash garment is 8 cal, it will actually provide 0% probability of you having that second degree burn. So this is an example video here of a garment being tested to the open Arc Flash test method. And it is how it sounds. The Arc Flash is conducted from several points. Just play this now. Then on the other hand, you've got the box test method. So again, it is what it sounds. It's more of a constrained and directed arc box test. And this originated from Germany. So it's well known in Europe, and it's still being used today. But the open arc test method is becoming a lot more popular in terms of what we've just seen, and especially now because of the new ELIM requirements. So from this video, you'll see a class 1 polo shirt being tested to a class 1 box test Arc Flash. Now the box test gives 2 values, either class 1 or class 2. The difference between both is the test current. So class 1, you might have a test current, you will have a test current of 4 kiloamps, whereas class 2 is 7 kiloamps. So we'll just play this video. So there you see it, the polo shirt has passed the test. It's stayed together and it hasn't penetrated to the mannequin, hasn't obviously caused a light. So that's the two types of test methods when it comes to arc flash. Also, with arc flash testing, it's important to know that the design requirements are similar to the flame retardant standard, but it does include additional requirements, such as the arc flash clothing, that it should cover the full body. So it should cover the arms to the wrists, the waist to the ankles, and also the torso to the neck. Garment closure should still function after an arc exposure. That's essential, especially when you need to take off the garment quickly after an arc flash has occurred. Accessories and hardware should not contribute to the severity of the injuries to the wearer. So that could include the studs or any exposed metal parts should not actually be touching the skin, the innermost surface. And it's also important that there's an overlap between the jacket and trouser if it's a two-piece solution you're wearing. So that it means that it should ensure nothing is exposed whilst undertaking various movements. In terms of arc flash testing, as we've already touched on, it's essential that both the fabrics and the garment is tested. It cannot be just the fabrics. And the other thing is the distance. So the actual amount of incident energy does vary on the distance you're stood away from an arc flash exposure. So being a foot away compared to a meter away is actually a massive difference when there's a risk of arc flash. Just some illustrative effects of that include an instant energy level of 1.2 cal. Well, that can cause a second-degree burn to skin. Then you have an instant energy level of 4 cal, which can actually ignite a cotton shirt. And then an instant energy level of 8 calorie can cause a third-degree burn. So again, it's essential to know what you're up against and calculate the incident energy level that's required to protect against. So just going on to clothing systems, protection can be arc flash protection can be greatly enhanced when you're layering. So it's essential to layer up with the right garments. And you'll see in this illustration here how a 7 cal polo shirt and a 14 cal sweatshirt can offer that even higher protection. So 7 cal plus 14 equals 21, but actually the combination of these garments achieve 31, and that's because of the air gap between both garments. Air is a poor conductor of heat, so it acts as an insulator. That's why we say 1 + 1 = 3 when you layer up. It's also important to make sure they are the right layers. Often we see individuals actually wearing their arc flash clothing, compromising by wearing an undergarment that doesn't necessarily meet the standards. In this video, we actually tested 2 arc flash polo shirts, and we wanted to see what would happen to the inner layer. So on the left mannequin, you've got an arc flash polo shirt with an FR and arc base layer. And on the right mannequin, you've got again an arc flash polo shirt. So it's right on it's okay on the exterior, but underneath you've got 100% cotton. So we'll just watch what happens here. So again, a very interesting scenario where people might think they're protected wearing an arc flash outer layer, but even 100% cotton that has a high melting point has ignited in this event. So even if it's 100% cotton or polycotton or nylon, we don't recommend that is worn underneath arc flash clothing. So just in the last section of this presentation, we'd just like to explain the importance of, whilst it's essential to make sure the garment is safe and does protect the wearer, it's also important to make sure the garment is comfortable and quality and designed well enough to wear, because otherwise your workforce won't necessarily wear the garments, especially when you're not looking. And it's essential that the people on the ground actually feel good in the garments they're wearing. So just some garment features to be aware of when choosing your PPE. It's important to look at the components of the garment. That includes the seams, the FR threads, the therm-safe components, the wrist tabs and the neck fastening, the reflective tape, the safety icon marking, and many more features. And also the design. So stretch panels, looking at those options in garments, and Napoleon pockets for harnesses, and also having the flexible sizes. So garments being available in many sizes to accommodate all shapes and sizes. And then the women's garments. So ensuring that women's garments are available for there's more and more women being employed in this industry. So just like to sum things up here. And and I trust this presentation has been useful. But what we'd like to finish off with today is art flash is a real risk, and it can occur in several industries. And we'd like to ask you the questions: is this a risk that your employees are facing today? Is your current PPE safe to wear and compliant? And if you have invested in the right PPE, are your employees wearing the PPE correctly? And are your company standards up to date with the right legislation and correct PPE standards? And how are your employees? You might want to ask them the question, how are they finding the PPE? Is it practical and comfortable to wear, as well as being safe to wear? That brings us to the end, Simon. Thank you for listening.
Thank you, Jarl. That's great. We'll start bringing in some questions. Before I go down to the guys, I've got a quick question for you. I've heard of something about inherent and non-inherent art flash, Jarl. Are you able to explain a little bit about what that means for us as well, please?
Absolutely, Simon. It's a very good point. I'm just getting the screen up here. It's a very good question. So there is a large difference between the risk of the inherent fabrics and treated flame retardant fabrics, and often people may not know the actual difference. So treated fabric can actually, a treated fabric is normally 100% cotton dipped in a chemical to make it flame retardant. And what tends to happen after a number of washes, the treatment wears away. And so after 50 washes or even less than that, it could be that your guys are still in the treated garments, but they're not protecting against an art flash. Whereas an inherent garment, the actual fiber of the garment is woven inside the fabric. So it doesn't matter how many times you're washing the garment, the fiber, the fabric won't lose its properties. Does that help, Simon?
Yeah, that's great. Thank you. Thank you for that. Got another question that's come in is, how could a site manager who might be doing his rounds distinguish between whether or not a worker has shown up with the correct PPE versus any other high-vis garment?
A great question. One thing we do onto our garment, we actually implement on our garments is what's called a safety icon, and that is a badge with the standards, just a simple badge with the standards with which the garment meets. So health and safety managers and site workers can go onto sites, site managers can go onto site and see the workers are wearing the correct clothing because of the safety icon. And it doesn't mean you need to open the garment to see what's on the inside of the care label.
Okay, thank you. Anybody else got any questions, guys? We've run out of questions and nobody else has asked anything else so far. Come on, guys, there's a lot of people out there with questions, surely.
Hi, Simon. Andrew Caulfield here. Can you hear me?
Yep, we got you. Thank you.
Okay. All right. Thanks very much, Jarl, for that talk on the PPE. I think my company I worked for before, MHI Investors, we dealt with you before as well, and the equipment is very good. But I've got a concern. We're focusing on obviously after prevention, reactive, where there's an arc flash and protecting the guys, but preventative, obviously we need to, you mentioned that as a 3 steps within the slideshow there, but is there enough focus on training designers and procurement people in requirements for arc flash protection? I'll give you an example here. For something like remote HV switching, we've seen so many manual switch gears. I think that video you showed was a racking of a manual breaker. Yeah. And they're still being used because they're cheaper than having a remote HV switching where the person's not even there, so they don't even need PPE because they're not standing near it. They're actually away from it when it's remotely operated. And that's one of my sort of concerns, is that there's maybe that training needs to extend to not just HSE persons, but and the workforce, as in the people at the coalface, but the people that are designing and obviously buying equipment as well, because that's what we found with the customer that bought equipment. We went back to them and told them the different requirements and what they could do to help prevent injuries, and they were quite happy to pay out that extra for that after knowing it. So there was a lack of training there.
Yeah, thanks, Andrew. That's a very, very good point, and I'm glad you've raised it. And it's not the first time it has been raised. And in actual fact, Simon has also raised this with us. Yeah. We've got so much within our company. We know so much, and it's really down for us. And when I say that, I don't mean that we have stopped learning. We're continuing to learn, but we've got certain information that, like you say, it's important to share to those that may not necessarily be health and safety related, but to the procurement staff, to actually the people that are working, you know, and have the risk of arc flash. So what we're looking at doing is actually having all that information in one area, if that makes sense, and making that visible to companies that do specify arc flash PPE, that can actually be accessed from anywhere and everywhere. So it could be accessed from health and safety, of course, and health and safety can pass that on to the technicians or to the engineers that actually face this risk. But it's a very good point you raised, Andrew, and glad you raised that.
Thank you.
I could throw a quick one in the mix there, Andrew. Might help a little bit. So, an ex-employer in my company moved off to another, and strangely enough, he ended up working on a wind farm that my company also works on. But this guy was now working in the substation. He was a trained HV switcher, authorized switcher with my company, and he's transferred over and he became a senior authorized person. They were doing maintenance on a generator. Let's just cut long story short. The poor bloke got full blast. He ended up in air ambulance going to Glasgow, and from what I can gather, he's still in intensive care. And this was over 4 or 5 months ago. He was very badly hit with it, and the resulting HSE investigation, which I believe is not actually fully closed, was absolutely distraught with the company, pretty much like you were saying, you know, the owning company, because their substation and all their switching equipment hadn't considered the hierarchy of controls safely and effectively enough. And they were saying there should be all sorts of interlocks put in place. Well, most of the people that on the call today that understand about switching, it's normally done with a remote cable well away from the blast area, which is where one of the serious hazards of arc flash kick in. And this wasn't available at this point in the substation. So you're absolutely right. The education, unfortunately, sometimes you get to boards of directors that are dealing with the money aspects, and they're sitting around a table in an office and haven't a clue the reality of what's on the ground until their company goes through the resulting pain of a serious injury or death and the HSE fallout on the back of it all. And you're absolutely right that like Jarl said, the PPE is the last line of defense, but people always see it as the first, unfortunately.
Yep.
And it's a tough one. Yeah.
Thank you.
No problems. We got a couple of other questions. One from Yazid. How can we be sure that the clothes didn't lose their resistance or probably have their characteristics altered after an arc hits them directly?
It's another great question. So if an arc flash hits the garment, and we would recommend certainly replacing that garment. So we wouldn't recommend to continue wearing that garment, and would recommend to dispose of it in a sustainable way. Trust that answers your question.
Thank you. And we got one from Kevin. Is there any special underwear recommended?
Yes. So again, as we saw in the video there, flame resistant underwear would be okay, but also if it can be specified to the arc flash standard, that would meet the right levels, if that makes sense. So that's what we would recommend for underwear.
Do they go through the same test method, Jarl, as the rest of the clothing? So they go through the box test or the open arc test as well, the underwear, do they?
That's right. Now, some of the underwear, such as socks or sports bras or the boxer shorts, that cannot be tested to a full garment test because skin is exposed, obviously. So what we would recommend there is that the fabric is tested, and that's why we can only claim flame resistant protection. But what we can give is the arc flash rating on the fabric of that garment. But with regards to a base layer top or base layer leggings, yes, they can be tested to the arc flash and the flame retardant test.
Yeah,
as we already touched on, flame retardant tests the fabric and the thread, whereas an arc flash tests the full garment, the whole heat transfer, the electrodes of the full garment to test the whole construction of the garment.
Great, thank you. Has anyone else got any questions, guys? Is there anything else from anywhere else? No? Okay, then, well, that probably leaves us at the end of today's session. Really, nothing further for us to add for any branch information or anything like that, but just like to say thank you very much to Jarl. I found that quite interesting. Thank you. Again, I've seen some of this before, but it always amazes me whenever I watch and listen to this, just because it's so technical. To me, it's quite easily forgotten some of the nuances that you have to consider in arc flash. So thank you very much, and
You're
thank
welcome.
you everybody for coming in and having a listen to us.
Thank you everyone.